Hey everyone, we are the group for Diophantus and we are tasked to report about Chapter 4, Mathematics as a Tool, which includes hypothesis testing and correlation in linear regression. Mathematics, a universal language of numbers and equations, has been an integral part of human civilization since ancient times. From accounting and engineering to scientific research and technology development, mathematics serves as a fundamental tool in various disciplines. Mathematics is the foundation upon which modern society is built. It provides us with the tools needed to measure, quantify, and make sense of the world around us. By harnessing the power of numbers, mathematicians have developed frameworks and theories that allow us to understand complex phenomena, solve practical problems, and make informed decisions. Furthermore, mathematics fosters critical thinking and problem-solving skills, which are essential in almost every aspect of life. Through the study of mathematics, individuals develop logical reasoning, analytical thinking, and the ability to approach problems systematically. These skills extend beyond mathematics itself and can be applied to diverse situations, leading to enhanced decision-making abilities and creative problem-solving. Hypothesis testing. Hypothesis testing is a systematic method used to evaluate claim or hypothesis about a population parameter. It involves collecting sample data and using statistical technique to determine whether the evidence support for the contradicts the claim. The process typically involves setting up competing hypotheses, performing statistical analysis, and drawing conclusions based on the results. Hypothesis. In hypothesis testing, two types of hypotheses are formulated, the null hypothesis or HO and the alternative hypothesis HA. These hypotheses represent opposing claims about the population parameter under investigation. The null hypothesis represents the default position or assumption. It states that there is no significant difference or relationship between variables or that there is no effect of a treatment or intervention. The null hypothesis often carries the notion of no change, no association, or no effect. The alternative hypothesis challenges or contradicts the null hypothesis. It suggests that there is a significant difference, relationship, or effect between variables. It represents the possibility of observing an outcome that supports a claim other than the null hypothesis. Two types of alternative hypothesis, the directional hypothesis and the non-directional hypothesis. Directional hypothesis, also known as one-tailed hypothesis, a directional hypothesis predicts a specific direction of the difference or relationship between variables. It specifies whether the observed effect will be positive or negative. For example, the new drug will improve test score. Non-directional hypothesis, also known as two-tailed hypothesis. A non-directional hypothesis does not specify a specific direction of difference or relationship between variables. It allows for the possibility of any type of differences. For example, there is a difference in test scores between Group A and Group B.
Example of hypothesis. Number one, hypothesis with one sample of one measurement variable. A generic brand of the antihistamine diphenhydramine markets a capsule with a 50 mg dose. The manufacturer is worried that the machine that fills the capsule come out of calibration and is no longer creating capsule with the appropriate dosage. Research question: does the data suggest that the population mean dosage of this brand is different than the 50 mg?
Example of hypothesis. Number one, hypothesis with one sample of one measurement variable. Responses variable, dosage of active ingredient by a chemical assay. On the average, the dosage sold under this brand is 50 mg, means dosage is 50 mg. On the average, the dosage sold under this brand is not 50 mg. Number two, hypothesis with two samples of one measurement variable. Obesity is a major health problem today. Research is starting to show that people may be able to lose more weight on a low carbohydrate diet than a low fat diet. Research question: does the data suggest that on the average people are able to lose more weight on a low carbohydrate than the low fat diet? Hypothesis about relationship to measurement variables. Research question: a financial analyst believes there might be positive association between the change in a stock price and amount of stock purchased by non-management employees the previous day. Stock trending by management being under insider trading regulatory restriction. Variables, daily price change information, the response to variable and previous day stock. purchased by non-management employees explanatory variable. These two different measurement variables. Hypothesis about the relationship to measurement. The correlation between the daily stock price change and the daily stock purchase by the non-management employees. The correlation between the daily stock price change the daily stock purchase by non-management employees. Hypothesis about comparing the relationship between two measurement variables in two samples. The correlation between the amount of the bill at a restaurant and the tip that was left is the same at the family restaurant as its same fine dining restaurant. The correlation between the amount of the bill at a restaurant and the tip that was left is the different at family restaurant than it is the fine dining restaurants.
For the illustrative example, in testing the hypothesis, we have a sample problem. So, the sample problem is the result of the last electrical engineering examination showed that the national passing rate is equals to 52.48. A sample of 82 electrical engineering graduates, electrical engineering graduates showed that the local passing rate is equal to 69.48, which both took the examination So the question is this significantly different from the national passing rate? The question is, the local passing rate is significantly different in the national passing rate. So as tackled by Ms. Samandal, we have 7 steps to test the hypothesis of the question. So for the first step, we have to formulate a null and an alternative hypothesis. So for our null, which is H sub O, states that there is no significant difference between the national passing rate and the local passing rate. While for the alternative hypothesis, which is H sub A, states that there is a significant difference between the local passing rate and the national passing rate. So, para mas madali, ganito siya. So, HO, P sub S is equal to P sub micro, P sub S is not equal to P sub micro. Yes, amen. So for the steps 2, we have to set the level of significance, which is mostly yung ginagamit na level of significance is alpha 0.0. Next is we have to identify the type of statistical test, kung two-tailed ba siya or one-tailed. So, para malaman if two-tailed or one-tailed, since we have an alternative hypothesis which shows non-equality, kasi English is equality, shows non-equality, then we will use two-tailed test. We will use the two-tailed test. So for the step 4, we have to determine the tabular value for the test on the table. So we can use Z table, which were tackled during our senior high school statistics and probability. But since the level of significance is alpha 0.05, we will use the Z table. So Z table. So at the level of significance alpha 0.05, the Z value that were obtained, the Z value that were obtained from the Z table, the critical value of Z is equal to positive and negative 1.96. So, dapat, if ito-test natin yung hypothesis ng NPR and LPR, dapat mas malapit siya sa critical value na sinet natin according to the level of significance, which is alpha 0.05.
Sympathetic error. Sympathetic error means that your measurement of the same thing will vary in predictable ways. Every measurement will differ from the true measurement in the same direction, and even by the same amount in the same cases. Cross error. Gross error occur when a mistake is made while recording data results using a measurement instrument or calculating measurement. Two-tailed test refers to the test of null hypothesis which the alternative hypothesis is not extrapolated directly critical region in both tails. Degrees of freedom. What are degrees of freedom? Degrees of freedom are the maximum number of logically independent values which may vary in a data. Simple. Degrees of freedom are calculated by subtracting 1 from the number of items within the data sample.
Here are the steps in testing hypotheses. First, formulate a null hypothesis and alternative hypothesis. So why do we need to formulate null and alternative hypothesis? It is to provide an approximate description of the phenomena. The purpose is to provide the researcher or an investigator with a relational statement that is directly tested in research study. Number 2, set the level of significance. The level of significance is a measurement which defines whether a null hypothesis is assumed to be rejected or accepted. It is expected to identify if the result is statistically significant for the null hypothesis to be false or rejected. 3. Identify the types of statistical tests as either one-tailed or two-tailed tests. Statistics hypothesis testing, we need to judge whether it is one-tailed or two-tailed test so that we can find the critical values in tables such as standard normal Z distribution table and T distribution table. Number 4, determine the tabular value for the test from the table. We need to identify whether it is a Z table or T table. Number 5, calculate the value of the required statistical test. Z equals to P sub S minus P sub micro over the square root of P sub micro over the quantity of 1 minus P sub micro over N. 6. Decide whether to reject or accept the null hypothesis. Null hypothesis testing is a formal approach to deciding whether a statistical relationship is a sample reflects a real relationship in the population or just due to chance. 7. We have the conclusion. It is the last steps in hypothesis testing. It is the part where researchers explain his decision and the implication of the result.
Correlation and regression. Correlation, we use correlation to denote the association between two quantitative variables. The association is linear, that one variable increases or decreases a fixed amount of a unit increase or decrease in the other. Regression involves estimating the best straight line to summarize the association. Regression analysis help us estimate the best straight line that summarizes the association between a dependent variable and one or more independent variables, enabling us to understand and predict the behavior of the dependent variable based on the independent variables. Correlation is a statistical tool used to determine the existence of a linear relationship between variables. It is a measure of strength of association among and between variables. Correlation is a statistical tool that measures the relationship between two variables. It helps determine if there is a linear association between them. The correlation coefficient, ranging from -1 to +1, indicates the strength and direction of the relationship. A positive correlation means that as one variable increases, the other variable tends to increase, while a negative correlation means that as one variable increases, the other tends to decrease. Correlation coefficient is a numerical measure to determine whether the two or more variables are linearly related and to determine the strength of the relationship between or among the variables. The correlation coefficient is a statistical measure that determines the extent to which two or more variables are linearly related. It quantifies both the direction and the strength of the relationship between the variables. The correlation coefficient ranges from -1 to +1. A value of -1 indicates a perfect negative relationship, where the variables move in opposite directions. A value of +1 signifies a perfect positive relationship, where the variables move in the same direction. A value of 0 represents no linear relationship between the variables. The magnitude of the correlation coefficient indicates the strength of the relationship between the variables. Values closer to -1 or +1 indicate a stronger relationship. The closer the correlation coefficient is to -1 or +1, the more accurately the value of one variable can be predicted by knowing the value of the other variables. It's important to note that the correlation coefficient only measures the linear relationship between variables and does not imply causation. It is a useful tool for analyzing the association between variables but should be interpreted along with other relevant information and statistical analysis. Types of correlation. Simple correlation can be positive or negative. Simple correlation measures the strength and direction of the linear relationship between two variables. It provides a numerical value called the correlation coefficient, which ranges from -1 to +1. A correlation coefficient of +1 indicates a perfect positive relationship. -1 indicates a perfect negative relationship, and 0 indicates no relationship. Positive correlation exists when one variable is directly proportional with other. Positive correlation occurs when two variables move in the same direction. In this case, an increase in one variable is associated with an increase in the other, and a decrease in one variable is associated with a decrease in the other. For example, as the number of hours spent studying increases, the test scores of students also increase. The correlation coefficient in positive correlation falls between 0 and +1. Negative correlation is when variables are inversely proportional with each other. Negative correlation occurs when two variables move in opposite directions. In this case, an increase in one variable is associated with a decrease in the other, and vice versa. For example, as the amount of exercise increases, the weight of individuals tend to decrease. The correlation coefficient in negative correlation falls between -1 and 0. Scale of correlation. Correlation is a statistical measure used to analyze the relationship between two variables. The scale of correlation ranges from -1 to +1. A correlation coefficient of +0.81 to +1.0 indicates a very strong relationship or association between the variables. When the correlation coefficient is close to +1, it signifies a strong positive relationship. This means that as one variable increases, the other variable also increases. Or as one variable decreases, the other variable also decreases. On the other hand, when the correlation coefficient is close to -1, it indicates a strong negative relationship. This means that as one variable increases, the other variable decreases, or vice versa. In both cases, the strength of the relationship increases as the correlation coefficient approaches +1. Therefore, if you have a correlation coefficient of +0.81 to +1.0, it suggests that there is a very strong relationship between the variables being analyzed.
So there are two statistical tools used to measure the correlation, which is the Pearson product moment correlation coefficient and the Spearman rank order correlation coefficient. Now we will tackle about the Spearman rank order correlation coefficient. So it is a non-parametric measure used to measure the statistical difference between two variables. It is used when the variables are ranked in order or in ordinal order. It is first introduced by an English psychologist who used the wrong formula, which is Charles. The formula for the Spearman correlation coefficient is this. formula for the Spearman rank or the correlation coefficient or rho, wherein this is the Spearman correlation coefficient, and this is the sum of the squared difference between ranks, and the n is the total number of cases. So there are steps in calculating the Spearman rho correlation coefficient. So the first step is to rank each scores in order. If ever na yung score ng isang sample is tag-tie, need lang natin kunin yung average niya para ma-rank sila. Then the second is to subtract each row by itself to get the corresponding ranks of each subject or respondent. Then the difference of the two rows that were subtracted are being squared, and this squared is, and the answer the squared, we will add them all to get the sum. Then we just need to substitute this formula into our substitute this value into our formula. So for our illustrative example, as shown in the table, we have 12 students in grade 9 which are used as a sample to know the achievement test in mathematics. So for our n sample, since there are 12 students, so our n is 12. For the scores, it is already given, the scores, and we just need to rank them. And as you can see in the table, they are already ranked. Rank of score 1 and rank of score 2. Next, we just need to subtract the rank of score 1 to rank of score 2 to get the difference between these ranks. As you can see in the table, the difference between the ranks are already given, which is from first student to the last student. So for the difference between ranks, we have, for the first student, we have 1, 2, -2, 1, 0, 3, -2, -1, 0, -0.5, -0.5, and -1. So for our next, to get this, the square rank of the difference between the two numbers, we need to square each of these. So if you're going to square this value, so this is b. So if you're going to square, we will get the value of 1, 4, 4, 1, 0, 9, 4, 1, 0, 0.25, 0.25, and 1. So after we square this value, we are going to add them all. We need to add them all to get this. So by adding them, we will get the total number of the square theta, which is 25.50. So this is the value for this. So now we're just going to substitute all of the value to our formula. So for our formula, we have Spearman correlation coefficient is equals to 1 minus 6 of the summation of the difference between the difference between the square of the ranks over the quantity of n cubed minus n. So just substitute the value. So 1 minus 6. The value for this is 25.50. For the n, since there are 12 students, so 12. So we're just going to use the PEMDAS rule, the basics. So we are just gonna extract the value of both the numerator and the denominator, which would give us 150, 53, and 1,760. Now we're going to subtract this and we're going to divide this and subtract it by 1. So our final answer is 0.91. 0.91. So as being tackled by Miss Cahill on the introduction of the linear and correlation regression, 0.91 in the scale of correlation is a very strong relationship. Which means that there is the relationship, which is the relationship between the achievement test of mathematics in score 1 and score 2 has a very strong relationship. Statistical use, aside from the Spearman correlation coefficient that we use to measure the correlation, is the Pearson product moment correlation coefficient. If yung Pearson, ginagamit natin siya rank or in order variable, for the Pearson correlation, it is used when the variable is continuous. So it is a parametric statistical tool used to determine the statistical difference between two variables, and it is used when the variable is continuous and or in scale. So for the formula of the Pearson correlation coefficient, we have this, wherein Pearson correlation coefficient is equals to n summation of xy minus summation of x summation of y over the square root of n summation of x squared minus the quantity of ex squared times n summation of y squared minus the quantity of summation of y squared. This is the formula, and we also have the alternative formula, which is r is equals to the sum of squares of xy over the square root of the sum of squares of x times the sum of squares of y. So r is the Pearson. For the x, summation of y, summation of x squared, summation of y squared. So makikita natin ito sa table. Like we can already know if yung value is x variable and y variable, which is the x is the independent and the y is the dependent variable. So for the alternative formula, which is which is the summation, I mean the sum of the squares of xy with the sum of the squares of x and the sum of the squares of y. So kuha lang natin yung value nito kapag tinatable form natin, which is mas material siya. So this is introduced by English mathematician Carl Pearson. For the test of significance of Pearson correlation coefficient. So what we mean by test level of significance, it is the probability of rejecting a null hypothesis, which is denoted by alpha. So lalaman natin yung test of significance ng Pearson if magkakamit siya ng type 1 error, which type 1 errors define that rejecting a null hypothesis when the fact is true. So for the confidence level, it refers to the possibility of a parameter to be utilized within a specified range of value, which malalaman natin dito sa which is C is equals to the confidence level equals to 1 minus the alpha, which is the alpha is the test level of significance. So there are common test of level of significance value, which is when the test level of significance is 0.010, it is 90% true, 0.05, 95% true, 0.01, 99% true. So you can obtain the test level of significance by the use of this formula, which is E is equals to R minus P over the square root of 1 minus R squared over N minus 2, or T is equals to R and the square root of N minus 2 over 1 minus R squared, wherein the N is the sample size or the sample population, sample size, while the R is the sample correlation coefficient of the two variables, which is dito, kaya ng kanina, Then the P is yung population, correlation coefficient, and the N minus 0 is the degrees of freedom. So yung computed t-value, which is ito, the computed t-value can be obtained from the t-table, which is t-table, medyo mahaba siya. Nasa naka-table yun ng critical values na nakabase sa degrees of freedom and alpha level na makukompute natin by using the t-value formula.
Coefficient of determination R squared. R squared is a statistical pressure that ranges from 0 to 1 and represents the proportion of the variance in the dependent variable y that is predictable from the independent variable x in a regression model. In other words, it tells us how well the regression line fits the data points. A value of 0 indicates that the regression line does not explain any of the variability in the data, while a value of 1 indicates that the regression line perfectly explains the variability. Of the regression line. The equation of the regression line represents the relationship between the dependent variable y and the independent variable x. It is represented as y equals mx plus b, where m is the slope of the line, which determines the direction and steepness of the line, and b is the y-intercept, the value of y when x is 0. The regression line is fitted through the data points to minimize the distance between the predicted values and the actual values. Ito yung gagamitin natin na formula para sa problem natin. So, n summation of xy minus summation of x summation of y over the square root of n summation of x squared minus the quantity of x summation of x squared, and summation of y squared minus the quantity of summation of y squared. So, since ang given sample natin is 12, which is yung n, so 12, then yung summation of xy is 15,520, then minus summation of x 103, summation of x 103, and summation of y 1,740 over the square root of 12, again yung sample, then 935, which is yung summation of x squared minus the summation of x squared, which is yung 103. Then, yung n ulit, yung which is the sample, yung 12. Then, summation of y squared, which is 268,100. Then, the summation of yx squared, which is the 1,740. Then, i-times yung dalawa, i-times yung 12 times 15,520 equals 186,204. Then, yung i-times din yung 103 sa 1,740, yung malalabasan is 179,220. Then, yung sa baba, para makuha ang answer na to, i-times natin ng 12 sa 935. So, 12 times 935 equals 11,220 minus 103 squared. So, since may squared siya, times natin siya by itself. So, 103 times 103 equals 10,609. So, 11,220 minus 10,609 equals 611. So, para makuha natin ang answer na 189,600, i-complete muna natin ito. 12 times 268,100 minus 1,740. So, since may squared siya, times mo siya by itself. So, 12,268,100 equals to 3,217,200 minus, so since may square root na, i-times natin siya by itself, 1,740 minus 1,000 times 1,000 So answer is 3,027,600. So the 3,217,200 minus 3,027,600 equals 189,600. I-minus natin ang 186,240. Makukuha mo ang 0.65. So, R equals to 0.65. So, ang 0.65 is may strong relationship siya. R squared is equals to the over the quantity of 0.65 squared. So, since squared siya, i-cancel siya by itself. 0.65 times 0.65 is equals to 0.4225. So, since kuha natin yung percent, times mo siya by 100, so makuha natin 42.25%. So, it implies that 42.25% of the variance in reading ability is explained by the variance in social media usage.
Test of significance, so how to solve the test of significance? Since the example that we're given was by Miss Sabandal, so this is the value, which is the level of significance, the computed, the T sub alpha 2.228, the value, the N sample 12, and the R is 0.65. So, yung sinabi ko kanina yung parang formula na binigay ko, so we will use that. So, the computed T is equals to R, the square root of N minus 2 divided by 1 minus R squared. So, since yung R natin is equal to 0.65, so we are just gonna put these values into their corresponding formula. So, dito na, 0.65, and the square root of 12 minus 2 over 1 minus 0.65 squared, which should give us the 2.77048, which is our computed t-value. Since the computed t-value is greater than our given value, which is 2.228, it implies that we can conclude that there is a significant relationship between the compared variables. Of the regression line, according to the example given earlier, gagamitin lang natin yung values. Example, kanina. So, for the equation of the regression line, we have y prime is equals to a plus x. Since we have two coefficient a, so we will use different formula for a and b to get the regression line here in the prediction equation. So, for the a, we have a is equals to summation of y times summation of x squared minus summation of x y over n summation of x squared minus summation of x squared. So, for the given yung mga value nito, yung parang nalita ko kung saan ko yung mga number, this is given from the sa example lang na kanina na binigay ni Miss Sabandal. So, for the summation of y, 1,740, summation of x squared, and 35, minus summation of x, 103, times summation of x, y, 15,520 over n, which is our sample, 12, times the summation of x squared, which is 935, minus summation of x squared, 103 squared, which would give us 46.38. So, for the b, we have n summation of xy minus summation of xy over n summation of x squared minus summation of x squared. Yung form yung given, yung mga numbers ito, kinuha lang din. For example, kanina, so 12, our sample, 12 times 15,520 minus 103 times 1,740 over 12 times 935 minus 103 squared, which would give us what? 11.484b. So, gagamitin lang natin ito, which is y prime is equals to a, which is yung a natin is 46.38, nandito na, plus b, which is our b is 11.49x. So this is the prediction equation for the equation of regression line of the example earlier. So mathematics as a tool has been helping us to predict future data that will help us either matutukan ng isang solusyon, isang problema by predicting what would be the outcome of the said problem. So, mahalaga siya sa ating buhay kasi kaya niya i-lessen yung damage ng isang certain problem sa ating paligid. So, gaya ng COVID-19 pandemic. So, maybe you are wondering bakit para nape-predict ng mga hospital, mga certain kung ilang cases kayang mabuo sa isang araw or yung percent ng mga taong nagkakaroon ng COVID. It's because by the use of math, the mathematics as a tool, which is our topic kanina. So, that's all. Sana may natutunan kayo. Chapter 4, Mathematics as a tool, which includes hypothesis testing and linear correlation regression.